Hi, so welcome to your last chemistry lesson today. And today we're going to be covering the noble gases, group 1 and group 7, and the trends in group 1 and group 7 reactivity. So here we have some chemistries, which have different elements as they're so colourful. Maybe some of you guys have seen them at school. Sometimes teachers make them. Okay, so let's start by covering some like the background on electronic structure. Okay, so electronic structure is to do with how electrons are arranged in the shells. So we have our nucleus, and then around it we have the electrons, which are circling in different shells. Okay, so electronic structure is all to do with how these electrons are arranged in these outer shells. Okay, so there's shells that represent a different energy level. So the first shell, that first energy level holds up to 2 electrons, and then it is full. From then on, all the shells hold up to 8 electrons only, and then they are also full. So the most stable electronic structure is that when the electron shell is full. Okay, so if for say hydrogen, we have 1 electron in its outer shell. So as it only has 1 electron in general, this is its outer shell. So therefore, it does not have a full outer shell and it's unstable. It wants to have 2 electrons in its outer shell for it to be stable. Okay. So this topic is electronic structure, noble gases, group 1 and group 7, and the trends in their reactivity. So now let's look at some electronic structure. So here we've got hydrogen, and hydrogen has 1 electron in total. Okay, and the first electron always goes in the first shell. So then we look at boron. So boron has 5 electrons in its atom. Okay, the first shell holds 2 electrons, and now it's full and happy. And the next one holds the last 3 electrons. However, boron wants to have 8 electrons in its outer shell. So therefore, it is an unstable metal. Okay, so also these numbers at the bottom, they're electron configurations as well. So it tells you that the first shell holds 2 electrons and the next shell holds 3. So what about oxygen? Oxygen has 8 electrons in total. As we know already, the first shell holds the 2 electrons, and then the next shell holds the rest. So therefore, its electron configuration is 2, 6. And once again, oxygen is not stable. It wants to have 8 electrons in its outer shell. And so therefore, when it reacts, it gains 2 electrons. Okay. So the way that the chemical reacts depends on its electronic structure. So chemicals always aim to have a full outer shell, which means they have 8 electrons in their outer shell, or 2 electrons if it's only in the first shell. So as for hydrogen, because it's filling up the first shell, it only wants up to 2 electrons in that shell. Okay. So yeah, as we see the next one, aluminium has 2 electrons in its first shell, then it has a full middle shell holding it to 8, and then lastly it has 3 in its outer shell. Okay. So if the first shell has 1 electron but the second has 8, would one of them from the second shell move to the first shell? So you never fill up your energy shells that way. So if say we had oxygen, and we say so oxygen has 8 electrons, yeah, in total. So if say what you say, we put 1 electron in there and then the rest of the electrons in the outer shell, this is incorrect. Okay, you only start filling up your outer shell once you have filled fully the inner shell. Okay, so this will never be the case. Your inner shell will always be full first, and then you add it to the outer shell. So it will look like this or like this. Yeah. Yeah, you can draw them in pairs. That's really common. So usually you do draw them in pairs. This is less so for oxygen. You'd usually draw them. So the first shell you don't draw as pairs, and the next shells you do draw them as pairs. Like that. Okay. So for transition metals, how do their shells look like? This is not something you need to know. This will be understood in A levels if you carry on to take A level chemistry. Please, can I repeat? I don't quite understand. Yeah. And today we'll be covering electronic structure, then moving on to look at noble gas configuration. Then group 1 and group 7, their reactivity and the trends in their reactivity. Okay. So if we say take oxygen, oxygen has 8 electrons, okay? So when we draw its electron configuration, we put O in the middle, and then we have our first shell. The first shell can hold up to 2 electrons, and then it is full, okay? So once we have filled it up with 2 electrons, we leave that shell, and we draw our next shell. The next shell is going to hold the remaining ones, because we've already got rid of 2, so therefore we have 6 electrons left. So the next shell is going to hold the 6 electrons that we have left over. Okay, so there we go. So although the second shell wants to hold up to 8 electrons, and when it has its 8 electrons, then it is the most happy. Okay, so that is why when oxygen reacts, it gains 2 electrons, and then it makes its outer shell full. Okay, does that make more sense? Okay, so in the periodic table, the group numbers tell you how many electrons are in the outer shell, as we said, and the chemical properties are determined by the number of electrons in an atom has in its outer shell. As chemicals always want a full outer shell, they always want to get to this stable electron configuration, and that's how their reactivity happens, because they either gain electrons or lose electrons to get to an 8 electron outer shell or a 2 electron outer shell if it is the first shell. Okay, and then they are stable. What about protons? So protons don't determine chemical properties, only electrons. So chemical reactions are to do with what the electrons do. Okay, so we can see this example here, right? So the group numbers tell us how many electrons are in the outer shell. So if we say take fluorine for an example, and we're going to draw the electron configuration of that. So fluorine has how many electrons? Can people tell me? People want to write down the answer in the chat function. How many electrons does fluorine have? Yeah, so the group number is the number of valence electrons. Brilliant. So perfect, it has 9. So how many electrons are going to go in the first shell? Brilliant, 2 electrons, okay? And then how many electrons are going to go in the next one? Yeah, so lots of correct answers. So it would be 7 electrons because there are 7 electrons remaining. Yeah, so that is why so how many electrons does fluorine want to have to be a stable chemical? It does want 8 electrons, and that's why when we see it in a bit, fluorine gains an electron and then it becomes a stable ion. Yeah, it wants to gain 1 more exactly. Okay. So it is also in group 7. Yeah, brilliant. Because it's in group 7, and yet, of course, as it is in group 7, we can see that it does have the 7 electrons in its outer shell, as we would have expected. So yeah, and then if you want to write down the electron configuration, you put 2,9. So 2 electrons, oh sorry, 2,7. 2 electrons in the first shell, and then 7 in the outer shell. Yeah. So do atoms join to other atoms to make ionic compounds, which makes them stable? So whenever an atom or a chemical reacts, it always becomes more stable, always reacts to become more stable. But yeah, so you can either have ionic compounds or covalent compounds. So you can also, that's how it happens. Are valence electrons the same as outer shell? Yeah, brilliant. Valence electrons are the same as outer shell electrons. The same. Okay. So yeah, that is how you draw your electron configuration. And the key thing is to remember that the first shell holds 2, and from then on it holds up to 8. So now let's look at our noble gases. So our noble gases is our group. Is our group 0 or 8. So it is this group down at the right, okay, indicated in pink. So noble gases, what are properties of noble gases? So noble gases have full outer shell of electrons, okay? So if, say, we took the first noble gas, which is helium, how many electrons does helium have? It has 2 electrons. And so therefore, in the first shell, we have 2. And how many can the first shell hold? And it's full, it can hold 2 electrons. So therefore, helium is happy because it has a full outer shell. So that is what is the distinct feature of a noble gas. So they have a full outer shell, and that is why they are so stable. So let's look at neon. Yeah, great input. So noble gas are stable and inert as they don't need to lose or gain electrons. So that's to do with, so gaining and losing electrons is what determines reactivity. Yeah, they do not react often. Do we have to know how many electrons are there in a certain thing of by heart? I don't really understand your question, sorry. So if we looked at neon, that is also a noble gas as it's in group 0/8. So neon has 2 electrons in its first shell. In total, it has 10 electrons. So it has 8 electrons left, and they go in its outer shell. And how many electrons does the outer shell want? It wants 8. So neon is a stable configuration as it has a full outer shell. Okay. So yeah, so as noble gases already have a stable configuration, it makes them very unreactive, as there is no tendency to react to modify their structure. So they don't want to modify their electronic structure, as it is already the most stable it can be. They are already very stable, okay? And that is why you see them as single atoms. That's why it's helium and neon and argon. They're all single atoms. How do the amount of electrons affect properties of an atom? So it depends on, so the number of electrons tells us how they're going to react. So either they're going to gain electrons to get to a full outer shell, or they're going to lose electrons to get to a full outer shell. So you're always trying to get to a full outer shell. That is always your goal. And the number of electrons in an element is the same number of protons in an element. So remember, your proton number tells you how many protons there are, but also how many electrons there are. So if we had 5 protons, that means we have 5 electrons also. Okay. If an element has 4 outer electrons, will it lose or gain electrons? This is dependent on if it's a metal or non-metal. So if you've got your line, you know, your staircase, these 2 are non-metals, so they're going to gain electrons. They're going to gain 4 electrons, and then these are all metals, so they're going to lose them. Okay, so that is how you decide if they're going to gain or lose. So it depends on if they're metals or non-metals. What are valence electrons? Those are your outer shell electrons. So yeah, here is your noble gases again. So now let's move on to our group 1. Where is our group 1 on the periodic table? It is here, as indicated in yellow. So what does it mean if the element is in group 1? How many electrons does it have in its outer shell? Write that down. Yeah, perfect, 1. And how might the group 1 metals react? So if they've got 1 in their electron in their outer shell, they are going to lose an electron. Yeah, to get to their full outer shell, as lithium is going to get 2 electrons in its outer shell, and it's going to be content. Yeah. So yeah, so they're very reactive, as they want to lose this electron, and it's only 1 electron they have to lose. They couldn't gain electrons because they'd have to gain 7 electrons to get a full outer shell. So that's why they always lose an electron to gain an outer shell, okay? Because it's really unfavorable to gain 7 electrons. Not so much. What happens in group 1 again? We're going to see that next. Okay. So group 1. Okay, so group 1 are called the alkaline metals. Yep. So they're commonly referred to as the alkaline metals. They're very reactive, and you must store them in oil to stop them reacting with oxygen. Okay. So at school, some of you guys may have seen an experiment where the teacher puts a group 1 metal into water, and you see it fizzing. There's like gas released. So yeah, the reactivity increases down the group is another key thing to note about group 1. I'm going to explain why. Okay. So some more properties. They float on water, so they have quite low density. They're soft metals, so you can cut them with a knife, which is not very typical of your metals, is it? That's quite a weird property. They're very reactive because they only need to lose 1 electron to get to that stable configuration of a noble gas with a full outer electron. Yeah. So we say took sodium. It's got 2 electrons in its first shell, 8 electrons in its second, and then 1 in its last. So once again, it just wants to lose this 1, and then it is happy because it has a full outer shell. Can elements exist without a full outer shell of electrons? No, they tend to always react to get the full outer shell. Are they colored compounds? No, they tend to be white. Well, as when group 1 metals form compounds, they tend to be white. Are group 1 metals more reactive than elements of group 2? Yes, they're a lot more. And do you need to know about group 2 for GCSEs? I don't think you need to know it in as much detail as group 1. So their reaction with water. So the metal floats on the water and fizzes, because when the metal reacts with water, it forms H2O. So this fizzing that you see, the bubbles being released, is hydrogen gas. So that's why you see fizzing, because hydrogen is being released in the reaction. So then hydroxides of alkali are formed, and these are soluble in the solution. So that's why they're called the alkaline metals, because they form these hydroxides that are soluble in the solution and form the alkaline solutions. Okay, and as we can see, the H2 is also released. So what do you think would happen? Okay, so let's take the difference. So if we have potassium plus water, what are the products going to be? So you don't have any idea. Okay, brilliant. So we're going to have potassium hydroxide plus hydrogen. Okay, is this balanced? No, it is not, as we have 2 hydrogens on this side and 3 on this side. So we're going to have to put a 2 in front of here two electrons fit, two electrons fit, and two electrons fit, and now it's all balanced. Okay, so yeah, it's really important to know the reaction of them with water and the fact that you form this alkaline solution. So your hydroxide is of course alkaline. You need to know the first 20 elements. Yeah, correct. So there will be a Kahoot, and we're going to understand why the reactivity increases down the group in a bit. And what happens if an element cannot react to get a full outer shell? So they will always react to get a full outer shell. Okay, so group 1 metals also react with oxygen to form the metal oxides. Another reaction you need to be aware of. So yeah, so this is the metal oxide. So if say we had our potassium example, what would happen then? We'd have potassium plus oxygen forming the potassium oxide. And once again, we'd have to balance it. Okay, so there we are. So you need to learn all these equations. So yeah, potassium reacts very fast with water and the H2 ignites. They also react with non-metals, and this is more vigorous down the group as it becomes easier to lose this electron. Okay, so key thing to remember is down the group electrons are lost easier, so the reactions are much more the reactions are more vigorous and faster. Okay. So now let's look at group 7, and then we're going to talk about the reactivity trends in the two groups, 1 and group 7. How do you explain the reactions of group 1 metals? You can say that the group 1 metals lose an electron because to gain a full outer shell, and then they become stable. Okay, so let's look at group 7. So group 7 are here, and as the group number tells us, they have 7 electrons in their outer shell. So therefore, they're going to gain 1 electron to get to that full outer shell of 8 electrons, which it is happy with. Okay, so they are commonly referred to the halogen, so that is their name. And they have typical properties of non-metals. So they have low melting points, low boiling points, and their melting point and boiling point increases down the group. So iodine is actually a solid at room temperature. However, fluorine is a gas, chlorine is a gas, bromine is a liquid. So yeah, their melting points increase down the group. They're like other non-metals, they're poor conductors of heat and electricity. And the molecules come in pairs, come in these pairs. Okay, so once again, the electronic structure determines how the halogens react with other elements. Yeah, brilliant. So someone said that they're diatomic molecules. Yeah, so they always come in diatomic molecules. They always come as F2, Cl2, Br2, I2. Okay. R group 1 and 7 are most reactive. So people have asked to go back to the other slide. So if you want to quickly take a photo of the slide. Okay, so let's carry on then. So the reaction of halogens, yeah. So the electronic structure determines the way they react with other elements. As they have 7 electrons in their outermost shell, they have to gain just 1 more electron to achieve the stable structure. So these ones react oppositely to group 1s. Group 1s, we said, lost an electron. And we said that the halogens gain an electron, okay? So do people want to see this slide again? So yeah, reactions of halogens gain 1 electron to get to their stable structure. Okay, so displacement reactions between halogens. We use displacement reactions to check the order of reactivity of halogens. So to find out which halogen is more reactive and which one is less. So more reactive halogen displaces the less reactive halogen. Okay, so we're going to see an example of a reaction like that. So the color of the final solution is due to the less reactive pair of the halogens. And you need to learn these colors. You need to be aware of these colors for your course. So what color chlorine is, what color bromine is, what color iodine is. So the reactivity down the group decreases, okay? So down the halogens, chlorine is the most reactive, chlorine is the next, bromine is after chlorine, and iodine is the least reactive, okay? So because bromine is more reactive than iodine, it will displace it, okay? So let's see an example of this. So here is our example, right? So this is a salt. So when you have your displacement reactions, you have a compound like this, and we're checking whether this halogen will displace this bromine and react with the potassium. Okay, so if the chlorine reacts with the potassium, that makes it more reactive. And then we will see the color of bromine. So that's how you determine the reactive. Yes, brilliant. So Cl is more reactive than the bromine, and that's why it has displaced the bromine from this compound. It has gone to react with the potassium, and the bromine becomes Br2. Okay, so the color change that we see here, if we look back on the slide, so we start with pale green, our solution, and we would go to yellow. So we start with the color of this, which is pale green. And the color change happens to see the color of this, which is yellow. And sometimes, yeah, we can say it's orange. The colors differ sometimes between the different examples. So these are the colors that are given in the AQA textbook. Yeah, so they would be correct either way. So it does form a brown solution. But usually for bromine, you can say yellow or orange. And then iodine is, I think it's a purple solid at room temperature, but in solution, it forms a brown solution. Okay. And we're talking about them in solution. Okay, should we try another displacement reaction then? So if, say, we had Br2 plus potassium iodide, is this going to displace it? Is there going to be a displacement reaction that occurs? What do people think? When we have a displacement reaction? Yes? Yes, brilliant. Why? Because bromine is more reactive than iodine as it is higher up in the halogen in the periodic table. Okay, so we're going to get displaced. We're going to form KBr plus I2. Okay, so then we obviously need to balance it. So we'll put a 2 in front of here, a 2 in front of here, and a 2 in front of here. And what is the color change that we're going to see? What color change would we see? So what did we say the color of bromine was? So we see this color first, so that's yellow or orange. And in the end, we're going to have the color of this, which is a brown solution, okay? So we see a color change from yellow/orange to brown when the displacement happens. What about if we had Br2 plus KCl? would we see any reaction occurring? Would it be our displaced Cl? No, no reaction, perfect. There will be no reaction. No displacement reaction occurs because bromine is less reactive than your chlorine. Exactly. Great. Okay, I'll quickly look at the questions. There's been some really good input as to why the reactivity increase or decrease down the group, but we're going to cover that now. And is iodine liquid or solid at room temperature? It's solid at room temperature, but it is obviously going to be in aqueous solution that is a liquid. Okay. If they are joined by covalent bonds in molecules with each, does that mean they don't need to react with other elements because forming diatomic molecules gives them a full outer shell? So yeah, diatomic molecules do have a full outer shell, but they can still react depending on the reactivity of the species you're reacting with. Why does reactivity increase down the group? So we're going to see that now. So that's group 1. So let's look at our trends. So trends down the group in group 1. So down the groups, the number of shells occupied by electrons increases. Okay. So if we had lithium, there is just one electron shell between the lithium and the outer electron, right? So however, if we go to sodium, we have the first shell, which has 2. Then we have the second one with 8. And finally, we have our third electron shell that contains the outer electron. Here. So atoms are larger down the group. As you can see, sodium is much bigger. And so outer electron is further away from the nucleus, and therefore there's less attractive force. So there is electrostatic attraction between the nucleus, which has the positive electron. So the nucleus has a positive charge, and the electrons have a negative charge. So there is electrostatic attraction between the outer electron and the nucleus. So as we go down the group, this outer electron is further away from the nucleus. So there is less attraction between the nucleus and the electron. And as we know in group 1, we want to lose the electron. So therefore, a weaker attraction between the nucleus and the electron makes it much easier to lose. Would the force be called electrostatic force? Yeah, or electrostatic attraction. So it is an electrostatic force. Brilliant. So outer electrons further away from the nucleus are less attracted. And the atoms lose electrons more easily down the group. Okay, so that's how you explain the reactivity in your group 1. Is intermolecular force and electrostatic force the same thing? Not at all. Okay, so intermolecular forces are to do with the forces between molecules. Electrostatic forces are to do between different charges. Okay, so for electrostatic force, you need different charges. Are the atoms more reactive as you go up? So in group 1, the atoms are more reactive as you go down because it is easier to lose an electron. Okay. So down the alkaline metals lose electrons faster. Okay, so down the group we lose electrons faster, and that's why the reactivity increases down the group, because it's much easier to lose the electrons down the group. So yeah, the trend in group 1, the explanation is they have larger atoms down the group. So the single electron in its outer shell that we are losing, is far less attracted to the positive nucleus. Okay, so there's a much weaker attraction between this outer electron and the positive nucleus. So because of these weaker electrostatic attractions between the electron and nucleus, we lose the electron much more easily. Okay, so the outer electron also experiences shielding from the inner electrons, which reduces the attraction between the opposite charged outer electron and nucleus. Okay. So what is shielding? Yes, good question. Is that explained next? So what shielding means is that so we've got a positive charge here, right? However, we've got these electrons that shield the positive charge away from this outer electron, okay? So this outer electron feels less of the positive charge in the middle because of the electrons between this outer electron and the nucleus, okay? So also there is electronic repulsion between these two electrons because they both have a negative charge, which also makes it easier to lose the electron. But shielding means that because of the electrons in between the outer electron and the nucleus, you see less of the positive charge in the outer electron. It has less attraction because of shielding. Okay. So because of the shielding, so shielding increases when there are more inner shells. So lithium has less shielding than where is it? So lithium, as it's only got one shell in between the nucleus and the outer electron, there is less shielding than in sodium, where we have this whole full shell and this other whole full shell between the electron and the nucleus. So therefore, down the group, shielding increases, which also reduces the electrostatic attraction between the nucleus and the outer electron, making it easier to lose this electron, and so making it more reactive down the group. Okay. So although the positive charge increases on the nucleus, the atoms are larger and there is a greater distance between the nucleus and the electrons, which means there is less attraction. And also there is a shielding effect, which outweighs the increase in nuclear charge. So because it's shielded, you can't feel the fact that, let's say, this one's only a 3+, but this one's 11+. Because of the shielding, you don't feel this extra positive charge. There's not additional attraction to this positive charge. Okay. So yeah, the shielding effect outweighs the increase in nuclear charge. So there's less attraction between the outer electron, and it's lost more easily. Okay, so the whole reactivity in group 1 is to do with the fact that as you go down the group, you lose the electron more easily. So therefore, that makes it more reactive. Okay, and that is because there is less attraction down the group because of the shielding, because there's the increase in atomic radius. Yeah. Okay, so now let's talk about group 7. So group 7, of course, it's opposite to group 1. It no longer wants to lose an electron, now it wants to gain an electron. Yeah? Okay, so why would the reactivity decrease down the group? So the size of the atom, the shielding and nuclear charge must be considered as we did for group 1. So atoms gain an electron in the outermost shell. But as we saw for group 1, we lost an electron much easier down the group because the electron was further away, there was less nuclear attraction due to shielding, and so it lost an electron much easier. That's why down the group, the atom gains an electron much harder, okay? It's much harder for the atom to gain an electron because down the group, the shell is further away and there is less attraction between the electron and the nucleus. Okay, so does that make sense? So down the group, it becomes harder to attract this additional electron, okay? So the way the group 7 reacts is by attracting this electron, by pulling it into itself due to the electrostatic attraction between the nucleus and the electron. But because the outer shell shielding, so when the outer shell increases, the shielding of the outer shell increases, there is once again a reduction in the electrostatic attraction. So that's why it's harder to gain an electron. So although we've got an increase in nuclear charge down the group, it is outweighed by the effect of the increased distance and shielding. Okay, so we always must think about the attraction between the electron and the nucleus and the nuclear charge. Okay. So yeah, so these are the key things to say. The electrostatic attraction is dependent upon the distance between the outermost electron and the nucleus, the number of occupied inner shells, as that is where the shielding effect comes from. So more inner shells, the stronger the shielding effect. And although the size of the positive charge increases on the nucleus, the shielding outweighs this effect. Therefore, larger atoms find it harder to gain electrons, but it is easier for them to lose electrons. Okay. Does that make sense? Yeah, so down the group, the increased nuclear charge is outweighed by the shielding and the larger atom size. So therefore, there's a reduced electrostatic attraction between the outer electrons and the nucleus. So therefore, electrons down the group are easier to lose, but they are harder to gain down the group. So that's why group 7 reactivity decreases down the group, and group 1 reactivity increases down the group. Okay, because group 1 are trying to lose an electron, whilst group 7 are trying to gain an electron. What is nuclear charge? That's the number of protons that are in the nucleus. So if, say, we took oxygen as an example, that's got 8 protons. So therefore, the nuclear charge is 8+. Okay, so it's just how many. So of course, so lithium, that's got 3 protons, so that's got a 3+, but sodium has 11 protons. So can you see the nuclear charge has increased a lot? There's a lot more positive charge. However, because of the increased shielding and the increased atomic size, there is still less attraction between the outer electron to the nucleus. And so sodium loses its outer electron much easier. Okay. So do people have any questions on this part? Any other questions on the reactivities? No? Okay, so should we start the Kahoot then? Okay. So the code's gonna come up and please join. So here's the gain pin. And so I'll briefly explain intermolecular forces at the end if we've got some time. Yeah, brilliant. So there was the question, so does the shielding outweigh the increase in nuclear charge and decrease the electrostatic attraction between electrons and nucleus? That's brilliant, great explanation. Making it easier to lose electrons but not gain them. Got the concept perfect, well done. Okay, so I'll give it another 10 seconds. And as usual, if you can't get onto Kahoot, please just write down your answers and just mark them as you go along. Yeah. Okay, so the numbers used for this table, let's start. So down group 1, the reactivity increases, decreases, or stays the same. Brilliant. Okay, so majority of the correct. So yeah, down group 1, the reactivity increases. Well done to Boris Johnson. Top again. Okay, it's true or false. Yeah, brilliant. Okay, so majority, majority wrong. So we'll see what's the correct order. Go through the answers. Oh, well done to Boris Johnson, keeping at the top. So what is the most reactive halogen in the group? Yeah, brilliant. Majority correct. So fluorine is at the top of the group, and as you know, the first one is the most reactive one. Okay. True or false? This displacement reaction would occur. Is this true or false? Brilliant, well done, majority correct. So fluorine is more reactive than chlorine. So it would occur. Boris Johnson keeps his lead. So what is the correct equation for the reaction of potassium with water? So what happens when potassium reacts with water? Okay, so we'll go through the answers. Well done to everyone. Okay, it's number 6. Are noble gases very reactive? So yeah, it is false. They're very not reactive and non-reactive elements. So the first shell can hold up to how many electrons? Yeah, perfect. So the first shell can hold up to, that's such a good turnout. Look, majority correct. Okay, last question. Group numbers tells us the number of, Well done. Most people got that correct as well. Brilliant. Okay, so let's see who came top. Well done to AM and Haley. And first is Boris Johnson again. Well done. Okay, brilliant. So now let's look at the answers to our questions. So first one, down group 1, the reactivity increases. So remember, easier, it loses the electron easier down the group, so therefore the reactivity down the group increases as it's trying to lose the electron. So CBrF is ordered in decreasing reactivity. So these two are correct. However, fluorine is the most reactive halogen, okay? So it should be FClEr, okay? So that would be the correct order. So the fluorine was like a little trick question. So the most reactive halogen is, as we've seen, fluorine, because it is at the top of the group 7 periodic table. So it is, and that makes it the most reactive. So does this displacement occur? Yes, it does. Fluorine is the most reactive halogen, so it's more reactive than chlorine, so it will displace chlorine for sure. Okay. So what's the correct equation for potassium and water? So potassium plus water, what did it form? It formed potassium hydroxide. And what else did it form? So you remember? It also formed hydrogen gas. So yeah, we need to balance it. So just put 2, 2, and a 2 of one sphere. So yes, key reactions to know and be aware of. So noble gases are very reactive. No, they are not. They're very unreactive because they have a stable electron configuration. The first shell can hold up to 2 electrons, and then it's a full electron shell. From then on, we can hold up to 8 electrons. And the group number tells us the number of outer electrons. Okay, and it also, this helps us determine how something will react. Okay, are CGP books help for revision? Yeah. I never use them. I preferred using my course textbook and course revision guides. Say if you're on the AQA, use the specific AQA revision guides. But we're going to be covering revision techniques on the 28th if you want to attend that. Okay, so now let's do some past paper questions on this topic. So let's look at this question. So we have been shown the electronic structure of 5 different elements. So we need to choose an element, one of these elements, to answer each question. So which of these elements is hydrogen? Do people have any ideas? Do you want to write the answer in? Which of these 5 elements is hydrogen? Yeah, brilliant, some great answers. So B is correct. We know that hydrogen has just 1 electron, and of course, in this one, we have just 1 electron in element B. Okay. So let's see the next question. Which element is a halogen? So which of these do people think is a halogen? If you want to write that down, which of the 5 elements are a halogen? So what group is halogen? It is in group 7. So what? Yeah, some great answers. Brilliant. So it would be D, because there are 7 electrons in its outer shell. So that is why it would be D. 7 electrons in its outer shell. So it is a halogen. Yep, group 7, halogen. Okay. So which is a metal in the same group of the periodic table as element A? So which one do we think is a metal that's in the same group as element A? Okay. Yeah, brilliant, some great answers. E and A are in the same group because A has 1 outer electron and so does E. And of course, we know that element B is hydrogen. So therefore, it is not a metal. That is why it is not B. Okay. So sometimes that catches people out. It is A and E because they are both metals in group 1. Yeah, so which element exists as a single atom? Yeah, I can see some correct answers. Okay, so we said that the noble gases exist as a single atom, okay? So the noble gases, and they always have full outer shells. So noble gases are the ones we're looking for with full outer shell. Yeah, so I can see lots of correct answers. So it's going to be C, because in C, we have 8 electrons in its outer shell. So that is a noble gas configuration, and therefore it is happy, it is stable, and can exist. But doesn't hydrogen have 1 electron in its outer shell? Yeah, so hydrogen does have 1 electron in its outer shell, but it doesn't exist as a single atom. So hydrogen exists as H2. That's the way it comes around. So you never see hydrogen as just H. You always see it as a H2. Was they're asking which atom do you see as a single atom? So like helium. Helium exists as just by itself. Yeah, so that's the next question then. So alkaline metals are part of which group? Yeah, great. Great answers. So how does the electron structure of group 1 give their characteristic properties? So how do group 1 metals react is what they're asking. So we say that group 1 have 1 electron in its outer shell, and therefore it wants to lose this electron, and the reactivity increases down. Yeah, brilliant. So it has 1 electron in its outer shell, make it very reactive because it's quite easy to lose 1 electron. So how are group 1 metals stored? Can we remember? Yeah, so we must store group 1 metals in oil to stop it reacting with oxygen in the air. Exactly. So it's very reactive. And what was our reaction with oxygen? If we had Na plus oxygen, what would we form? People remember? What do we form with oxygen? Sodium oxide, yeah, with a chemical structure, with a chemical form of Na2O. So we needed 2 here. No, we need a 4 here and a 2 there. Okay. Should we see the last? Okay, so let's finish doing one of these questions. So read the word equation for this reaction between chlorine and sodium bromide. So chlorine plus sodium bromide would form what and sodium bromide? Sodium chloride, sorry. Yeah, perfect. Some good answers. Bromine, okay. So what would be the color change observed? Can anyone remember what was the chlorine color? Yeah, so it starts as a pale green and it goes to form what color? Yeah, brilliant. Yellow / orange. Brilliant. Okay, so this is a key. Always look for your color change to tell you whether the reactivity. Okay, so why does iodine not react with sodium bromide? Why does iodine not react? So as we know, iodine is less reactive than bromine. It is further down, so it's down the halogen group. And we know the reactivity decreases down the halogen group. So yeah, iodine is less reactive than bromine, so therefore it does not displace bromide. Okay, so we'll stop with the questions here. Do people have any last questions on this topic? Any last quick questions? And then we will finish. Okay, no questions. Okay, do you want to quickly say your question? Go to the previous page. Yes. This page. Where are you talking about this one? Yes, so it's a diatomic when it is in its element form. It is now in a compound form. So that's why it's Na2O. So they're diatomic when they are in their element form, okay? So like H2Cl2. But when they're in a compound, they don't need to be diatomic because they have reacted. So the presentation is on YouTube. So you can get all these slides, you can rewatch this and just take notes from the slides of YouTube. Is Na diatomic? No. No metals are diatomic. Sodium is a metal. Does the color change depend on the one formed at the end? Yes, it does. Okay, so your color of your solution is always it's not the compound, it's always your element, your elemental halogen. Okay, so in this case, at the start we had chlorine as just chlorine, which was pale green, and then we went to bromine, which is yellow orange. So the halogen determines the color. Okay, so I think we'll finish up here then. And have a great holiday, everyone. And thank you for attending these revision classes. Bye.